Okay, welcome everyone. Here we are in my new lecture, magnetic effects of electric current. Okay, so around conductors through which electric current flows, there is a magnetic field. So here is kind of massive, but there is a magnetic field. Okay, so you have here a conductor. We all know what is a conductor. We all know what is an electric current, and when in the conductor you have an electric current, you will have a magnetic field going around the conductor. So this finger shows the direction of the current, like so, and these other fingers show the direction of the magnetic field. So like this. You see? Okay, here a conductor is going up, magnetic field is going to go around the conductor in this direction. If the conductor goes down, then magnetic field is going to show in the in this direction. Okay. So let's hear this now. I'm gonna remove all this text. Now you can see here we have a conductor and current. This is a plus and a minus sign. So here the current will go from the plus to the minus. Let me just make this little bit now. Yes. Okay, so for example, we want to see here in the middle of the right side where the magnetic field lines going to go, in which direction. So current goes from plus to the minus. So current goes this direction. Now you can see the right hand. You have to use your right hand. This shows the direction of the current, and the other fingers show the direction of magnetic fields. So here we go. Now we have electric current going towards us. So electric current goes like this, and the magnetic field lines go like this. But now you can see in the middle there is one line going from here to here, and this line, now you can see that here you have a south pole, and here you now have the north side. And if we make more loops, we'll get a solenoid like here. If we make more loops, we'll get a stronger magnetic field with more lines going through the middle of these loops, and you will have a stronger magnetic field. So current goes here we have a plus, here we have a minus. Current goes in this direction, so current goes like this, and then the magnetic field lines are gonna go in this direction, like this. You can see here. This becomes the north side, and this becomes a south side. And more loops and more magnetic field lines you have. Magnetic field lines don't mix each other. So you will never have something like this. One magnetic field comes like this, and they don't cut each other, never. So they are they are uniformly posted. They are always one next to the other. So never they don't. These lines never cut each other. And let me show you how electromagnet works. So now, how can you make an artificial magnet? Now you have an iron. You all know how an iron looks. Let's say that it's a cylinder, and now you make loops. On the iron. Now you have here plus and a minus sign. You put, I don't know, a generator or a battery. So the current will go from here to here. So now you can see that current is gonna go in this direction. Now it's gonna go in this direction. This is gonna become north side, so the magnetic field line is gonna go like this. And this will become a north side, and this will become south side. So now the iron, when current is going through this wire, becomes a magnet. So now you can attach a car. Now you can pull a car, and now you have, I don't know, some kind of car here. So this is a magnet, and you move the car where you want. You disconnect. You disconnect the generator so that there won't be any current flowing here. Now there are no magnetic fields. And then the iron is gonna become same old material, and you know, and it's gonna go away. So it's gonna fall. I don't know where you wanna lay it. That's how it's done in the car. So when you disconnect the current, where you don't have any current, this is a same old metal iron. But if you have many loops around this iron and you have a flow of current in the iron, then this iron becomes an electromagnet. So, or a magnet, which we call in electrical engineering electromagnet. Thank you for watching, and see you in my next lecture.